Hey everybody, today doing a video on indexing. Indexing, for those of you who don't know, is essentially having multiple possibilities and using a number system to determine what you want to do. So it's an alternative for custom events, but it can be used for things that you wouldn't use custom events for, all sorts of stuff. So I have a few examples set up here, but just to clarify and demystify what I'm talking about here, first of all, the reason we would use indexing is several reasons. One, if you have a certain type of code that you want executed, but you want that code to only be executed given certain criteria or certain conditions. So in this case, one of the examples I have here, I have 3 rooms and I have lights in each room, and depending on which light we want to turn on or off, we provide a different index. So in this case, this would be index 1, this blue room, the yellow room is index 2, and the white room is index 3, for several things. But if I had a custom event set up to turn on or off lights, then I would need 3 different ones if I wanted these 3 different rooms to work independently of one another, even though they're using the exact same code. So that's not really that great of an option unless you want all of them to turn on and off at the same time. So if you want the same code, which is a light switch in this case, but you want to be able to affect individual instances of that code, then you can use an indexing service. So essentially what we do is we have, in this case, an integer, which does not pass an activator. So this works fine for lights, but would not work for giving player health or a checkpoint system or something like that. But it can be manipulated to force an activator somewhere in there. I also have another example using a player resource which does pass an activator, so we can use it for things that require an activator. But for this light example, we have an integer. It's titled index_int. Anytime we change the value of this integer, every reference to that integer is going to signal any unchanged output. So we want this to have an initial and minimum value of 0. It can be -1 or really any value, but whatever that value is, you don't want that value to actually do anything. So our 0 value does not correspond to anything. That way we can force it to change and force this unchanged output. So in this case, we have our index 1 stuff here. So anytime we change this integer to 1, this onChange is going to come out. It's going to test that integer and see if it is equal to 1. And if it is, then we do our index 1 stuff. The good thing about this is the core of it is this right here. Well, not that. We have our index variable, in this case an integer, onChanged, test, and our index value. So if we want whatever comes out of this equal to happen, then we just need to change our index value to 1. If this was 2, we change our index value to 2, and this will come out. Any other value will not pass through this compare. So that's really the core of any index code. So that's what I've got here. You can ignore this. I will demonstrate what that would be for momentarily. But anyways, we have index 1. So when we change this, which is being changed here, this switch with the label blue over it, on used, we change this integer, which is our index integer, to 1. And I'll go ahead and say that this one changes it to 2, this one sets it to 3, and this panel sets it to 4. So anytime we set this to 1, it has to change, so it must be any value other than 1 in order for that on changed to occur. So we set it to 1, it would be 0, change it to 1, so on change comes out, it checks, it is equal to 1, so this equal output happens. In this case, we're signaling a sequencer, and the index 1 of the sequencer, the first output for this sequencer, is going to turn on the light. I have these off by default. If you want them to start on, and the first signal you would want would be to disable the light. So the sequencer, obviously, run 1 output per signal. Shared sequence isn't really going to have much of an effect, except if you had this off and player 1 came and switched it, the light would turn on the first time, but then player 2 could come and switch it, and it will try to turn it on again, so it won't actually do anything. So you want that to be on. In this case, some cases you might not need that. Repeat sequence we also want on because we want to be able to toggle. So the first output turns it on, second turns it off, the third would go back to index 1 because it's set to repeat, and every time we hit that switch, it's going to toggle based on the sequencer output. So that's how that works. But what I have is this big chunk right here that I can pick up and I can put anywhere else and just change the index. Change it to 2, and anytime we change that index variable to 2, it will affect this light only. And I say only as if I didn't already have an index 2, which I do. And what I just did is exactly what I did to fill these other 2 rooms. Quick selected, copied the whole thing, and stuck it down right there. And then just went in here and changed it to 2. It's doing the exact same code, but we don't want all of them to be affected at the same time, so we can't use a custom event for that. Now you could just hook up chains directly from here. This is very close, so not a great example for that, but if you had 100 lights and you wanted them all to work independently, but you didn't want a bunch of chains everywhere, which could slow things down, make it real yucky and hard to read, and you wanted the option to easily copy and paste a new instance of this same stuff, then this is going to be the way to go, because I can put it over here. I have index 1 through 4. You will have to keep track of which index does what, where it's being affected. But I have 1 through 4, so I can make this 5, and anytime I change that value to 5, it's going to do the exact same stuff to this light. And of course, it's not limited to lights. You don't have to use sequencers. You can do all sorts of stuff. But it is an easy way to use essentially a custom event, but have it specify which thing you want to do just based on changing a number. So again, this is exactly the same as what's over here, except this is the only value that needs to change to indicate that if we want to affect this, we just change that value to 2. If we want to affect this, we change the value to 1. On changed happens, it comes through, tests this, it is 1, so it'll affect it. Comes through here, if it's 1, it's not going to pass through there, nothing will happen. And here, again, exact same thing. This is index 3. So if we want to affect that, we just change this integer to 3. Now, if this was the only thing that you were doing, then after you went through and tested, if it was equal, you'd come down here and you'd set this back to 0. That way that on changed is forced, so you can run the same code in sequence. So if I wanted to turn this on and then immediately turn it back off, if that value was still 3, it's not going to produce this on-changed output. So you want to set it back to 0 or -1 or whatever your null value is. I'm not doing that here because I am doing something else with this index. and we are using it to signal a sequencer and change the index of the sequencer to that value. So on changed here, testing, making sure it's greater than 0, because if it is 0, we don't want it to come through and set it back to 0, and it could get real weird. So if it's greater than 0, then we're going to set it back to 0. But we need to have a delay here, otherwise it won't pass through the other compare, or whichever one was placed first. It will go through, but then it's immediately going to be set to 0, and the other stuff won't happen. So we need a delay setting it back to 0 if we're using more than one mass of stuff. If we're using that same variable in more than one place, then we need to have a delay to make sure that everything is capable of being processed. So in this case, you can use a sequencer or a switch for this particular example, but here we do want to change index to our index value and then signal. Make sure your execution order is change index first and signal second. If you don't want to do that, or whatever, you can just put a little delay on here, and that would work as well, but you will have that slight delay. So we change index of the sequencer to our index value, and then again you can use a switch, which would not require you to use change index and signal. But in some cases you may want to be able to signal this again. This is not the best case. This should be a switch and not a sequencer, because we're not going to have the option to continue the sequence at any point in time. So a switch would be the best thing here. I put a sequencer, so sue me. One output per signal. Repeat sequence is not going to be necessary here. Doesn't matter if you want to use a sequencer. Again, this particular case should be a switch. And shared sequence we also want to be true, although in this case I don't think it needs to be, and it's not going to matter anyways because there's no activator. So that could be a little weird. It might not work at all. I'm not sure how that works if there's no actual activator. But if it's index 1, it just plays a sound. It says 1, 2 says 2,
3, 4.
Okay, so anytime we change this value to 1, it's going to signal all the onchanged, much like a custom event on signaled, but then it's going to come through this next step and check to see. We set it to 1, it's going to pass through here, it will not pass through the other ones, and then it's going to signal this and either turn this on or off. It's also going to signal this on changed, like a custom events on signaled output. It's going to check to make sure that it is greater than 0. If it is, then we're going to change this index or signal switch to the value of our index, then immediately signal it, and it's going to signal the appropriate index. And a tenth of a second later, it's going to set it back to 0, which will force an on-changed again, but it's not going to pass through any comparator because none of our indices are 0. So, yeah. There's that. There's how that works. Without an activator, none of these things required an activator, so we can use an integer. And it's a lot easier, especially if you're doing something with a sequencer or a switch, because this will not take anything but an actual integer or persistent integer. So you can't use a player resource here. You can force a player resource to be converted into an integer per player if you wanted to do it that way. But if you would do something like this and you're using a player resource as an index, then you would have to do that conversion, but I didn't set up anything for that in this example. Second example, again, indexing using player resource. So it passes an activator, so anytime it does change, we have the activators, the activator gets passed through that onChanged. So we can do stuff like teleport, which does require an activator. You can do stuff like give weapon, remove droppable, you know, that sort of thing. And this player resources don't work with demons, so you couldn't use that for demons, but you could use a cached object and integer index type thing to force a demon as an activator if you wanted to do something like that. But anyway, here I've got 3 pads, blue, yellow, and white. We're using the same index numbers for our areas. This is index 1. Again, this is set up exactly the same, except we have a player resource instead of an integer. And our onEqual here is simply going to teleport. And since this is the only thing we're doing with it, we can change that value back to 0 from here, which will force another onChanged, but it will test. And it won't pass through here. There's 1, here's 2, and here's 3. So if I step on blue, on entered, we're setting this to 1. When it's set to 1, it's going to force an onChange. It's going to test. It will be 1. So it's going to come over, it's going to set it back to 0, and it's going to teleport the activator, which will be whoever stepped into here. So that's pretty much it for the examples. I do have one more thing over here using the same index as here. Like I said earlier, you don't have to use the same code for everything. I have 3 separate instances of a light switch, but I can use the exact same integer for any amount of code at all. So here I have index 4, which will pass through just like the light switch, and it actually comes through and uses a sequencer the same way as the light switch. However, in this case, index 1 of the sequencer will spawn an unwilling, and the second index of the sequencer will finish and remove that unwilling. However, in cases like that, if there's an alternative way to do something, then you're going to want to change the index of this sequencer back to the value that it should be on to force, you know, whichever you want. So in this case, our second index of the sequencer, our second sequence, is to finish the encounter and remove the unwilling. If he's already dead, and we go and we signal the sequencer, and we signal number 2, it's going to attempt to finish the encounter, and it's not going to do anything. So you'd have to hit the switch twice in order for it to spawn again. So what I've done is on encounter finished, we set the index of the sequencer back to 1. So if we hit the switch on this panel over here, set it to 4, comes through here, spawns this guy, and he's still alive, and we hit the panel again, it will remove him. If we hit the panel one more time to spawn him again, and we kill him, then it's going to set the sequencer back to 1 as if that finish encounter happened, but it was done manually by killing him. So when we come back and we hit it again, instead of trying to finish an encounter that's already done, it's going to signal this first index and spawn them again. So yeah, there's some indexing examples I'll go in here and demonstrate. Probably not the best examples I can give, but essentially it is a custom event, but a conditional custom event. So you only have to worry about one variable, and you have to worry about keeping track of which index does what, which you can use, you know, hidden world text or something to keep notes around the map. But whoops, I stepped into a pad there. So blue player resource is passing an activator index 1. It's going to teleport us in front of blue room, and it sure did. Yellow I already walked into. White takes us to the white room. And because we set it back to 0 after I get teleported, then we can use the same pad over and over and over again. Here, blue, if we used a custom event and all those lights were hooked up, then they would all turn on, and if I hit it again, they would all turn off. So in this case, we are using one single variable, and we're able to do multiple things using kind of the same code. And also, it does say 1. That's index 1. Here's number 2. Says 2. Turns on that light. We can hit it again. Says 2. Turns off that light. We can hook up another sequencer or another switch or something to have it not say anything on the second time around. But that's a little convoluted. So, yep, we can do whatever we want here. See? So that's a neat thing. Spawn, remove, unwilling. Index 4 says 4. Spawns them. If we hit it again, it will finish the encounter and remove them. Alright. But if we start it, it's going to spawn them. That's the first output of the sequencer. If we kill him, that sequencer just got changed to index 1. So if we hit it again, instead of trying to finish it, it spawns him. Spawn, and because he's still alive, index 2 of the sequencer removes him. That's pretty much it. If anyone has any better examples that they'd like to see, I have some more convoluted ways that I have used indexing in other maps. It's very good for teleporting, especially if you have a huge map that's, you know, spanning the entire board. You might not want a huge chain going from one corner of the void all the way to the other side. So if you have, you know, something here, a teleporter pad, and you have index 7 teleport destination over here, you have no need for a chain, and all you have to do on this end is change your index variable to 10 in this case, and then on the other end you have that unchanged. Check it to see if it's 10. If it's 10, teleport the activator over there. In that case, it would have to be a player resource, or if you wanted to use a single integer for all indices, then you could use a cached object to do that sort of thing, to force an activator on the back end. But yep, that's it. Thanks for watching. Send me requests and that sort of thing. Like if you liked, dislike if you didn't, all that good stuff. Yep. Bye bye.